Dear students, in this lecture we are going to discuss the concepts of set theory, the fundamental concepts of set theory, such as the basic ways of describing sets, use of set notation, finite sets, infinite sets, empty sets, subsets, power sets, equal sets, equivalent sets, disjoint sets, countable, uncountable sets, and etc. Now, start with the introduction of set theory. Set theory aims to at providing foundations for mathematics. Sets appears in all branches of mathematics. The main developer of set theory is George Cantor. The word set is synonym with collection, class, or aggregate. Basically, set theory is the mathematical theory of well-determined collections called sets of objects that are called members or elements of the set. In mathematics, the word set is used to represent a collection of objects viewed as a single entity. The individual objects in the collection are called elements or members of the set. These elements are said to belong to or contained in the set. So in this lecture we only deals with the sets of mathematical objects, for example sets of numbers, sets of geometric figures, etc. Now we will start with the definition. This is introduction about the set theory I have given. Now start with the definition of set. A set is defined as a collection of distinct objects of same type of or class of objects. The objects of a set are called elements. These are elements. This is the object of a set. These are elements called elements. Objects can be numbers, alphabets, names, etc. This can be alphabets also, numbers is already written, names also. So for example, I have written A equals to in a bracket 1, 2, 3, 4, 5. This is one set. A is the set of numbers containing 1, 2, 3, 4, 5 elements. A set is usually denoted by capital letters and their members by small letters. Now we will see what is the standard notation. Like suppose it is written in this way, it is read as X belongs to A, means X is an element of set A. If it is written X, this symbol with cut means X does not belong to A, that is X does not belong to set A. Third one, this means empty set. This means 5 means empty set. Fourth, universal set. U means universal set. N means the set of all natural numbers. I, comma Z means the set of all integers. If it is written I naught, Z naught, this means the set of all non-zero integers. Set of all non-zero integers. If it is written I plus, Z plus, Z plus means the set of all positive integers. C comma C naught means the sets of all complex, non-zero complex number respectively. Q, Q naught, Q plus means the sets of rational, non-zero rational, positive rational numbers respectively. If it is written R or R naught, R plus, this means the sets of real number. R means sets of real number, R naught means non-zero real number, set of non-zero real number, R plus means the set of positive real numbers. Now the question is how you will represent a set. There are two ways to represent a set. First one is tabular or roster form of a set, and second is builder form of a set. In tabular form of a set, simply a set is defined by actually listing its members. Suppose you have written a set P and you have written in bracket their members. So this is the form, tabular form, and this is the way in which any set can be. This is one of the way in which a set can be represented. Now the second one is builder form of a set. In this form, a set is defined by the properties which its elements must satisfy. For example, P is equal to X such that X belongs to N. N is a natural number. X is a multiple of 3. T equals to X such that X is even and less than 9. So we will consider those numbers X such that X is even and less than 9. So what will be the set? T is equal to, it will be 2, 4, 6, 8. They are even and they are also less than 9, isn't it? Now see types of sets. There are many types of sets, like finite set. If a set consists of a specific number of different elements, then that set is called finite set. For example, P is equal to X such that X belongs to N and X belongs to X lies between 3 and 9. Q is equal to 2, 4, 6, 8. This is finite set. Infinite set. If a set consists of an infinite number of different elements, the set is called infinite set. For example, I is equal to the set of all integers. This is infinite set. The set of all integer is example of infinite set. Now we will discuss countable set. What is countable set? A set is called countable set if it is finite or denumerable set. Example, every finite set is countable set, and second, every denumerable set is countable. Uncountable set. A set is called uncountable set if it is infinite and is not cardinally equivalent to n, that is natural number, or is a non-denumerable set. For example, first, the set of complex numbers is an uncountable set. The set of real numbers between two integers is an uncountable set. Theorem 1. There is one theorem. Every subset of a countable set is countable. This is very important. Every subset of a countable set is countable. Now see the proof, how you will prove it. Let A be a countable set. then A is either finite or denumerable set, as before, as I have told you in the definition of countable set. Let us first consider A be finite. But we know that every subset of a finite set is finite, and hence it is countable. Second, now you let A is countably infinite set, then A can be written as this: A equals to, in bracket, A1, A2, A3 dot dot. Let B be a subset of A, then if B is equal to 5, 5 is empty set, then B is countable. But if B is not equal to 5, then B is equal to some members an1, an2, an3 dot dot, where A and I belongs to a set A, this one. From 1 B is countable, hence proved. Now two more sets you can see. Disjoint set. What is disjoint set? Two sets A and B are said to be disjoint if no element of A is in B and no element of B is in A. Do you understand? Two sets A and B are said to be disjoint if no element of A is in B and no element of B is in A. For example, I have written a set R equals to, the members are A, B, C, and you take another set S is equal to K, P, M. So R and S are disjoint sets because neither R has the elements of S in it nor S has the elements of R in it. That's it. So this is R and S are disjoint sets. Family of sets. If a set A contains elements which are itself sets, then it is called family of sets or a set of sets. For example, A equals to, I have written the set inside the set, 1, 2, 3, 4, null set also. A is set of sets. Okay. Now I will see subsets of a set. What is subsets of a set? If every element of a set A is also an element of set B, then A is called subset of B and is written as A subset B. See this definition. If every element of set A is also an element of set B, then A is called subset of B and is written as this. This is a symbol of subset, A subset B. In this case, what B will be called? B will be called as superset of A, and it is given as A subset of B. It means A subset B is equal to X such that X belongs to A, and that implies X also belongs to B. See the properties of subsets. First property. Some properties of subsets are as follows. First one is, every set is a subset of itself. This is very true. Every set is a subset of itself. Second, if A is a subset of B, then B is called the superset of the set A, as I told you here. If A is a subset of B and B is a subset of C, then A is a subset of C. That means what? A is a subset of B and B is a subset of C. This implies A is a subset of C. Fourth, phi is subset of every set. I told you here, every set is a subset of itself, and phi is a subset of every set because in every set phi has there. That is implicit. Fifth number, if A is subset of C and B is subset of A, then A equals to B. That is, if two sets A and B are subsets of each other, they are equal. A is subset of B, B is subset of C, and C is subset of A, then A equals to C. Now, n is a subset, natural number is subset of all integers, and all integers are subset of rational numbers, and rational numbers are subset of real numbers, and real number is subset of set of all complex numbers. This is the meaning of this thing. Now we will discuss some proper subset, some another subsets, that is proper subset. If A is subset of B and A is not equal to B, then A is said to be the proper subset of B. See the example: A equals to 2, 3, 4, B equals to 2, 3, 4, 5. A is proper subset of B. Second one, the null set phi is a proper subset of every set. Improper set: if A is subset of B and A equals to B, then A is said to be an improper subset of B. For example, A equals to 2, 3, 4, B equals to 2, 3, 4. Then this is A is improper subset of B. Second point, every set is improper set of itself. Every set is improper subset of itself. Now, what is singleton set? A set is said to be singleton if it contains only one element. That is, in any set, if there is only one element, you can say it is singleton set. Now, how will you give the example? Let A is equal to X such that X is neither prime nor composite. It is singleton set as it contains only one element, and that is 1. 1 is the element. This means 1. So set has the element 1. So this one is singleton set. So students, we have discussed the definition of set, different types of sets, and some theorem and some properties. So in this way I am ending this first lecture on set theory. We'll discuss many more about operations of sets and etc. in the next lecture, that is in lecture 2. Okay, thank you so much. And if you have any problem, we are having also the discussion classes. We will discuss there also. Okay, thank you so much.